do a couple more problems. And this is homework 4.3.6. It's more inverse trig. And so we'll just come down towards the bottom. And I already did a couple of these with you guys. So we don't need answers. So let's take a look at, let's just do 31. So 31 is not too terrible. Again, we're building our triangle. So remember, first we have to build our triangle to find the inverse of this. And what we end up with for our triangle is, we know that tangent would be y over x. So this would be 5x over 1. And so now we need to find the hypotenuse. And so we know that h equals the square root of x squared plus y squared, or y squared plus x squared. It doesn't matter. So this is 25x squared plus 1. And so that is our hypotenuse. So now when we're finding sine of theta of this triangle, what we're really finding is opposite over hypotenuse. So this would be 5x over the square root of 25x squared plus 1. We can rationalize the denominator by multiplying the top and the bottom by the denominator. So let's just do that. So if I multiply the top and the bottom, this becomes 25x squared plus 1. And on the bottom, it's also the square root of 25x squared plus 1. And so work our way through. The top is 25. The top is 5x times the square root of 25x squared plus 1. And if I multiply the identical thing by itself, like the square root of x times the square root of x, we're left with whatever's under the radical, and the bottom becomes 25x squared plus 1, and we're done. So pretty straightforward, not too terrible. Let's do 33 and 34. So 33 is a little harder. So we're finding tangent of sine inverse of x plus 1, and they're giving us some values that x cannot be equal to. So we start with sine inverse of x plus 1, and so we know we have to create our triangle. And we know that sine is opposite over hypotenuse. So this would be the opposite is x plus 1. And there's no denominator here, but there's an implied one. And so we need to figure out our y value here. And we'll just say, we know that y is equal to, just using the Pythagorean theorem, is equal to the square root of 1 squared minus x plus 1 squared. And we need to clean this up a little bit and simplify. So we know that y is equal to the square root of 1 squared minus, remember, this is going to be x plus 1 times x plus 1. And we multiply that out, we're going to get x squared plus 2x plus 1. And our negative is going to distribute, and these terms are all going to become negative. So we're going to get negative x squared minus 2x minus 1. And our 1 and our minus 1 are going to reduce. And when we simplify this, we're left with x squared, negative x squared, minus 2x. And so that's my y value. So we come back up here, and now we need to figure out what the tangent of this angle theta is. So tangent theta is y over x. So this is equal to x plus 1 over the square root of negative x squared minus 2x. And we're going to have to rationalize this denominator again, or as well as the other one. So just go with some green. We're multiplying by the square root, the top and bottom. We're going to multiply by negative x squared minus 2x. And we're going to have to multiply the bottom by the same thing, negative x squared minus 2x. And we're going to simplify that and clean that up. And so tangent of theta is equal to our original factor, x plus 1. Remember, we're multiplying this whole thing together, times the square root of negative x squared minus 2x. And that's all over negative x squared minus 2x. Done. So those aren't too bad. You just have to remember your triangles. We'll do 34 too, just to do a little bit. And okay, so 34. Again, we're going to have to build our triangle. Let's just build my triangle right here. And we know that sine, so we're finding the inverse sine, would be opposite over hypotenuse. So this is 3x, and the hypotenuse is 4. So we need to figure out this y value, or the adjacent value, however you want to think about it. And so we know that our y value is equal to the square root of 4 squared minus, in parentheses, 3x squared. So y is equal to the square root. This is going to be 16 minus 9x squared. Remember, the exponent distributes to both terms. So when we find the cosine of this angle, we're looking for the adjacent over the hypotenuse. And so let me think about this a little bit. So cosine theta is equal to adjacent, which would be the square root of 16 minus 9x squared over the hypotenuse. Pretty straightforward, not too terrible. Hopefully that's okay for you guys. And I'll see you next time.